Hi, so this is a walkthrough of Transformation Challenge 11 to try and help you understand and practice going through these challenges before they are due later this week. So I have set up the Desmos challenge. Number 6 I found matches this one as closely as possible. I did have to do a little bit of messing with it. So I've set it up to start here, and I want to see if I can play with it till I can get it under 5 transformations, and preferably see if I can get it to 5 of the simplest possible transformations, maybe using the origin. I may have to do some things where I translate or where I rotate or reflect across something other than the origin, but every time I can use the origin, I'm going to try and do it. So paying attention to the origin is here just above point A. So if I wanted to rotate this, because I'm going to need to, I want to use that point that it defaults to because that matches the origin in my coordinate frame. And let's see, if I try this, it'll look just like that. But having played this game for a little while, I know that I'm going to need to reflect out of there. So if I reflect, then somewhere where I can get it out of the box without crashing. Now it's upside down. So maybe if I change how I do that and rotate it some different way, let's try clockwise instead. What happens if I then reflect it out? Okay. Well, that looks a little better because now it looks like just another reflection might get me where I want to go. So if I reflect maybe across the axis, every time I can do the axis, I should do the axis because the math is just a little bit simpler. Now I've got it the right shape. I'm going to have to get it the right size too. So where am I at? I'm at 1, 2, 3 steps right now because the first 2 were just putting me in the right position. What if I dilate? I really would like to dilate about the origin. If I do that, well, I left the screen. But if I had been keeping track of the points, I may still be able to salvage this. I should try and shift it down and see where I'm going. So I want it to come down so I can see where it is. Oh, there it is. Okay. So it came down. It's in the right orientation. This is pretty good. I'm going to just change my translate to see if I can get it to hit this thing. Oh, so close. Oh, so close. Oh, all right. So I got it in 1, 2, 3, 4, 5 steps. It's all 5 steps, but I think I can describe them all. So let's see how that works. First thing I did after I set it up with the first 2 steps here was to rotate 90 degrees clockwise. So that's what I'm going to write right here. Rotate 90 degrees clockwise about origin. So if you remember, I left the thing here at the default position at the origin, and I rotated 90 degrees clockwise about the origin. So my coordinate notation is going to take my XY, and I'm in another room here, but XY, and take it to now a rotation 90 degrees clockwise. I'm going to refer to the slides where I have that information. So in the slideshow composite transformations, my rotation by 90 degrees, this is the very last slide, number 12. If I wanted to go clockwise 90 degrees, that is y negative x. So I come over here and write y negative x. Now, here's the thing. When I go to the next coordinate notation, I'm going to start with y comma negative x and go to the next transformation where these will be my input. And I believe I talked to you about this in class. We're going to compose as we go, if you will. So let's check out what our next transformation is. Reflect. Now I can't remember exactly. It looks like I reflected across a vertical line. Let's play it all and see what happens. Okay, this is the setup. All right, then I rotated. I reflected across a line that wasn't the origin, and it was a horizontal line right about here. So it looks like I was reflecting about a line right about here. So I'm going to have to figure out what that line is. 1, 2, 3, 4. Let's assume these are all 1. So I'm going to say this is the y equals 4 line, and I want to reflect about it. Oop, I forgot to draw my my first rotation. So going back, rotate clockwise. Clockwise would have been this way. So I'm going to rotate it so that it's here. That point's going to stay where it is. That point just next to A stayed where it was. So this is going to stay, that's my first T prime, A prime, R prime, whatever. So it looks like my T prime is down in this corner. And then my R prime is here. It's so small, but I do my best. All right, so now we're going to do the the second transformation, T2, where I reflect across the line y equals 4. Now, a reflection is a plus or minus, but I have to do that weird sort of shifty thing. And since I'm moving my object, it's going to end up above the previous object. That's a y transformation. So my x is actually going to stay the same. All my x's are going to stay the same because it's not moving any left or right. It's only moving up and down. And my y is going to have to be, let's see, I have to move it down by 4, then change the sign. So it's going to be y minus 4, then change the sign, and then add the 4 again. This is a 4. But I have to remember that this was my input. So actually it's minus x. Ooh, minus y. Okay. Let me go back. Here we go. It's actually going to be, I'm going to erase my x and put in the y that goes there, because all my x's are now my old y's, and I'm going to erase my y and put in negative x. Woo! So this is y comma negative parenthesis negative x minus 4 parenthesis plus 4. I'm going to do a little simplification of this before I move on because I don't want to have to put all of that as it is into the next one. So to simplify, oh, by the way, this was a reflect across y equals 4. Okay, so I'm going to simplify this. Negative x minus 4. If I distribute that negative, I get x plus 4 and then plus 4. And so that's x plus 8. Ooh, the whole thing simplifies to x plus 8. Which is awesome. So that's what I'm going to write on the next line. I'm going to write that my input to the next transformation is going to be y comma x plus 8 goes to, all right? So that's really fascinating that it ends up being so simple, right? But that's the beauty of composite transformations. So I've penciled in where my t double prime is, and my next transformation, if I play all again, and this is the setup, okay, now I rotated 90, reflect it across that line. Oh, I reflect across the axis next, and then I dilate. So if this next one, that's a reflect across x equals 0. That's the vertical y-axis. X equals 0 as the line, right? And so the whole thing's going to flip like that, and my new T triple prime is going to be over here, and my R triple prime is going to be over here, and it'll be oriented correctly at that point. So a flip across the x-axis moves things horizontally. It sort of shifts things around all the points horizontally. So my y is going to stay the same, and my old y was x plus 8. X plus 8. That's staying the same. Because vertically nothing's happening. Everything is happening horizontally, so I'm messing with this first coordinate. My first coordinate, though, is everything's gonna change to a negative. So instead of y, I'm gonna have negative y. Now, it's a good idea to test these points at some point and make sure it does in fact land where I go, but I'm gonna make a separate video for actually recording and testing the points. The next thing I did was dilate, and I left the dilation at the origin, but that grew my shape off of my page, so I would really like to keep it on the page. Instead, so to do that, I'm going to dilate about this point here that's on my shape. That should hold on to it and sort of pin it to the paper. I'm going to dilate by 2, by a scale factor of 2, from the point 0.8. And that fully defines my dilation, and now everything's going to grow by a factor of 2. So instead of going half over and then down, I'm going to go 1 over and then down, and my whole shape should just grow where that 1.08 stays put. I'm pretty sure that's 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So that 0.08 stays put on my shape, but everything else grows. So this is now my R quadruple prime, and this is my T 4 prime. Maybe I'll just write a little 4 there. All my other pieces have, oh, that's not my T, sorry. That's my F. Looking at the original shape, I lost track. I forgot that I flipped. So sorry, this is my T4, and this is my R4 in green around this corner. This corner up here is my F4. Okay. So how do I describe that dilation by a factor of 2 from 0.8? Well, the first thing I do is I multiply everything by 2. Is it the first thing I do, though? Actually, I need to shift it down to the origin, then multiply by 2. And so in my x, everything did grow. Yeah. So I'm going to shift it down. So my x doesn't shift it down. My y shifts it down. So I'm going to have my x plus 8, my starting point, and I'm going to shift it down by 8. Then I'm going to double it, and then I'm going to shift it back up by 8. And what that does is bring it down to the origin, grow it, and then put it back up where it was so that it doesn't get further from the origin. Because if I just doubled it, you saw it went off my page. So now my y is already on the axis. I should just be able to double, or I'm sorry, my x coordinate, it's the negative y here. My x coordinate should just be double the previous x coordinate, negative y. So this is a little messy. Again, for the next step, I would like to simplify it. So I'm going to do a little bit of simplifying here. And my next step will be negative 2y, comma. Now, okay. Well, x plus 8 minus 8 is just x. That's fascinating. So these actually cancel each other. And I get, I have to distribute my 2 just to the x, so it's 2x plus 8. That simplified a lot. Let's watch the next video for the points and finishing this.